Testing. Welcome again, class. I know the last time we made this video, it got to be kind of long, and I apologize for that. I knew it was kind of a long lesson. This one will be much shorter. The other good news about this lesson is it's on section 9.2. As the syllabus indicated, we're going to spend 2 days on this particular lesson. 9.2 then means we will not be assigning anything today. So we're just going to go through 4 examples. These are examples that we kind of began last time by just looking at the null and alternative, but now we're going to complete the entire test for these 4 examples, and then we'll be done for the day. One of the things that's true about all 4 of these examples is they are all two-tailed test examples. We'll be doing single-tailed tests the next time we make this video. So for right now, we're looking at two-tailed tests, and we're going to grind through 4 examples. As you read this first one, purchasing manager for a large insurance firm, I must decide whether to upgrade the office computers. We've been told that it is $2,100. That is a key word there, as we mentioned last time. That's screaming at us, two-tailed test. We take a sample, and it shows up to be a little bit more than 2251. The real question here is this number 2251, is it so far away from 2100 that we have mathematical evidence to say 2100 is not accurate? Or is this 2251 within reasonable variance that we wouldn't have really any evidence to doubt 2100? That's what this is about. It says at a 5% level of significance, that's like saying alpha is 5%. They're asking us to run a critical value as well as a p-value test of hypothesis to support our answer. So I'm going to be doing both here. And we'll be doing that quite often here today, just so that you get a sense of both of them, all right? To help you understand the difference, I'm going to do a critical value on the left side, and I'll be doing a p-value on the right side. On your next exam, sometimes I'm going to ask you to do specifically a critical value test. Other times I'll ask you to be very specific and do a p-value test. And still other times I might not specify which one you have to use. If I don't specify, you could use either one, the one you're more comfortable with. But be ready to do one of each, because I will at times ask you to do one critical value. Other times I'll ask you to do a p-value, okay? These are going to come right off of that page of notes that you had. So I first of all have step 1. I want to again remind you I'm numbering these steps. So step 1 is going to be the null and the alternative hypothesis. As I mentioned, all 4 of these are two-tailed tests. Two-tailed tests are the easiest ones to set up null and alternative. The reason is two-tailed always have the null to be equal and always have the alternative mu to be unequal. That's standard procedure for two-tailed test. That's why they're easy to set up. There are some other parts that are tricky, but the null and alternative are really easy. In this case, I'm testing against the 2100, or it's not equal to 2100. Step number 2, I need to list my alpha level. It was told to run it at 5% level of significance, so that alpha is 0.05. I need to list my sample size next, and we had a sample of 64 here. Because 64 is greater than 30, I know that I'm going to be using a Z statistic. Because I'm doing a critical value test, I need to get my rejection region, RR, rejection region. So I'm going to list that now. Okay. In this particular example, I'm going to list it below here if you don't mind, just because I'm a little short on space and I know I have to write too small sometimes. So I'm going to put my rejection region below here. I'm choosing to do that because I want to leave some space here to show once what I'm looking at visually. I'm looking at testing against a mean of 2100. That number always corresponds to our null and alternative hypothesis number. This one, though, is two-tailed, meaning I'm looking to see if it goes far enough to the left, one tail, and far enough to the right, or far enough to the right, two tails. So if it varies from 2100 in either direction far enough, then I can cancel off the 2100 and say that it's either one side or the other. We call that two-tail. But what that means is this rejection region really has two lines in the sand. One line is over here if it goes far enough less than 2100. The other line in the sand is over here if it goes far enough more than 2100. So I have this line in the sand, which is going to be Z is less than some negative Z score. Or I'm going to have this line, which is Z is greater than some positive Z score. Now, getting those Z scores. The 5% is the two tails put together when it's two-tailed test. The alpha is split in half for a two-tailed test. I'm going to say that again. The alpha level is split in half. That means I've got 0.025 over here, 0.025 over there, which leaves 47.5 in each side. Or we could say that's the same as a 95% confidence interval. Remember those? We memorized those Z-scores for 95% confidence. They were 1.96 and a negative 1.96. Those are my lines in the sand. Those are my rejection regions. If I go far enough over to the left of that, that would be less than a negative 1.96. That would be over the line. Or if I go over this line to the right, that would be more than 1.96. Do you see why I have two lines with a two-tailed test? So those are my rejection regions, both of those. Now I go to step number 3. I got to calculate the actual Z-score. You remember it was your sample mean minus your hypothesized mean, that's always the number up here, divided by your adjusted standard deviation. So in my case, I look at my sample. It had a mean of 2251, that's X bar, minus the hypothesized mean 2100 divided by standard deviation of 812 divided by the square root of my sample size, which was 64. When you calculate that out, it turns out to be, I'm going to find that here a moment, 1.49. First of all, it's a positive because the 2251 was more than 2100. It was over here someplace. The question now, did it go over the line or not? Well, 1.46 is about right here. It did not go over the line. That means it's within what we call reasonable variance of 2100. Even though it didn't exactly equal 2100, it's close enough that we have no evidence to doubt that 2100 is correct. So because of that, here's my concluding statement. My Z equal to 1.46 is, here's that phrasing again, insufficient evidence to reject our null. It's like saying I don't have enough evidence to reject that it's 2100. I got to continue to assume that it is 2100. So we continue to assume, notice that phrasing, continue to assume. Now I need to put it in context. I continue to assume the average cost of our laptop computer is 2100. I'm going to say is still $2,100. Notice I wrote that all out. Again, notice steps 1, 2, 3, 4. I don't write 1, 2, 3, 4 and have all the parts in the correct place. I lose points. I must write this all the way out. Again, this is, think of it as an argument you're going to use to convince an audience. I don't need the graph. The graph was there just to help you understand what's going on. But you do need all of that part right there. On your next test, you'll be doing this 4 or 5 times. 4 or 5 of these tests, you have to be able to write them all out, okay? Think of this as a report that you would be given to your boss. It needs to have all the significant parts in it. They must be put in the right place. They must make a logical argument to go through. They asked me in the problem, if you remember, to do both a critical value, which we just did, and a p-value, which we're going to do now. Couple things to notice. The p-value conclusion is found a little bit in a different manner, but it's always going to be the same conclusion. So my step 4 on the left and my step 4 on the right better both be the same, or one of them is wrong. They should either both say insufficient evidence, continue to assume, or they should both say sufficient evidence to reject null and conclude the alternative. They both should say the same thing. But let's look at the parts that are different. I'm going to put those parts different in red, or I'm going to underline them once, okay? My null and alternative will not be any different. So I'm going to still have the null to be that the mean is equal to 2100, and the alternative is going to be that the mean does not equal 2100, the exact same. Number 2, I'm going to list my alpha level to be 0.05, and I'm going to list my sample size to be 64. And I'm going to list what statistic I'm using, Z statistic. Here's the part that's going to be different. I'm not going to list my rejection region because I don't use this type of rejection region anymore. Instead, I'm going to go right to the beginning of step 3. So I have one part that's easier. Number 2 gets easier here, but step 3 is going to get a little tougher. It's going to have an extra part. So here we go with step 3. It starts out the same formula, x bar minus mu divided by s over radical n, same formula, putting in the numbers, 2251 minus 2100 divided by 812 square root of 64, and I get 1.46. If you check out the printed notes, it says at this point for a p-value test, I have to find the p-value. What I'm really looking at is I'm looking at finding what is the sum of those two tails. For 1.96, the sum of those two tails was alpha. The question is for 1.46, what is going to be the sum of those two tails? In other words, I'm looking at this. I have 1.46, that's my z-score. And technically I have to consider that it could have gone in the other direction that far. What are these two tails for 1.46? Well, to find that, I go to my chart. 1.4, I said 6, but it was 9. I apologize. That 9 would have been over here as well. Sorry. Same overall result. Okay, 1.49. I go to 1.49, I get 4319 from the middle out. That's not the tail, 4319. So that means I have 4319 here, 4319 here, which means the tail is the complement of that with 0.5. So if I take 0.5 minus that, I'm going to have a 1, I'm going to have an 8, I'm going to have a 6, and a 0. And I'm going to have the same number out here. Those two values together become my p-value. So how do I write that over here? I say the following. P-value, it's going to be 2 of these. So I'm going to put a 2 here. Each one of those is 0.5 minus 4319. So I would take the 0.5 minus 4319, subtract it from 0.5, and double it. So when I double that, 0.4319, I end up with 0.1362. Basically, that 0.1362 are these two tails together. Now, here's the deciding factor. I take my p-value and I compare it to the alpha. I'm going to say that again. Take my p-value, compare it to the alpha. If this p-value, which is a probability, the probability is less than alpha, that means I went over the line. If this p-value is not less than alpha, it means I did not go over the line. Okay? So I'll say that again. If the p-value is less than your alpha, you reject the null. If the p-value is not less than alpha, which in this case it's not, 13% is not less than 5, I have insufficient evidence. That is why my step 4 is going to be same conclusion as this one. Basically, though, just says instead of z equal to 1.49, it's going to be p-value. So p equal to 0.1362. Now the rest is going to be exactly the same. Is insufficient evidence. And I'm going to go blah, blah, blah. Blah, blah, blah is all of this rewritten. And on your daily assignments, you cannot go blah, blah, blah. You need to write it out. I'm just trying to save us time for this video. Critical value has a rejection region. Notice here I did not. But the p-value, I've got to find that p-value, which I did not have to do over here. Those are the two parts that are different for a critical value, p-value. You will be asked to do both, but I need to tell you most of the time in the business field, they use a critical value test. Most of the time in the medical field, they use a p-value test. They want to know exactly what that probability is. We just want to know whether we reject or we have insufficient evidence to reject. Here they want to be a little bit more precise. That's an example using both a critical value and a p-value. Underlined parts are what's different. Example number 2. Sorry for the delay. We started this one in the last time we met, and we set up both the null and the alternative hypothesis. Now we're going to run the full critical value test, and I'm going to run a p-value test again, both of these in this particular example. One thing that is going to also be different, first of all, notice it says average of 18.6. That's like saying the average is 18.6. That's screaming at me two-value test, okay? What is going to be a little different about this one is that I'm going to give us multiple alpha levels. I'm going to say test at 10%, 5%, 1%. Most of the time, we're just given one of those. But once in a while, they'll give you all three, okay? Because it has some implications, which I'll talk about in just a moment, all right? So let's start off with the critical value test. The critical value test, you remember, step 1, you need to set up the null and alternative hypothesis. The null is H sub 0. The alternative is the second one, always listed as the second one. Again, these are easy for two-tailed. Because the average is 18.6 or average of 18.6, it means that my mean equals 18.6 or my mean does not equal 18.6. Step number 2, I'm going to list my alpha levels, but this time there's multiple ones. Alpha is 0.10, alpha is 0.05, and alpha is 0.01. I'm also going to list my sample size. We took a sample of 36 months. That's 30 or more, so that means I use a z-statistic. Kind of written sloppy there, I apologize. I hope you can still read it. I need rejection regions now for every one of these. So for the alpha 10%, again, what does that mean specifically? What that means is this. I take that 10%, because it's two-tailed, I'm splitting it in half, 5 over here, 5 over there, which leaves 45, 45, similar to that 90% confidence interval. If you remember, for 90%, these were negative 1.645 and a positive 1.645. You could have looked them up in the chart with 45 as well, but those are what you would get. Those are my rejection regions for the 10%. So my rejection region here would be Z is less than negative 1.645 or Z is greater than a positive 1.645. My other rejection region would be for 5%. Well, what would that one look like? It would have looked like this. The 5% means I take the 5% and cut it in half because it's two-tailed. Half of 5 are those values, which means that leaves 47.5 in here. That would have been comparable to that 95% confidence interval. Remember, those were 1.96s? 1.96, 1.96. So if I go over the positive, or if I go over this negative, so my rejection region on this side is less than a negative 1.96, or I'm going to write it like this, greater than a positive 1.96. Finally, I have the rejection region for the 0.01. That would have been like a 99% confidence interval. You remember that one had a negative 2.575, or Z had to be greater than a positive 2.575. So I had 3 rejection regions here because I had 3 alpha levels. All right. Continuing on then, I need to find step number 3, my Z-score, X bar minus mu over S divided by the square root of N. X bar is my sample mean, which was 17.1, minus the hypothesized mean. Mu is always the number up here in your null and alternative, so it's 18.6. Standard deviation was 2.4, divided by the square root of your sample size, 36. Well, as it turns out, that Z-score happens to be a negative 3.75. Wow, that's off the chart, correct? Because if you remember, if I were to look at my chart, in fact, this one goes down to 2.6. If you're in your book, it'll go down to about 3.1, but that's the very edge. You remember also we said about 3 standard deviations and you get about to the edge. Well, I am 3 3/4, so I'm way over here. 3 of them would took me about to the edge. All of these were different lines, right about in here someplace. I went over all 3 lines in the sand. It's less than a negative 1.6, it's less than a negative 1.9, and it's less than a negative 2.575. It's over the line in all 3 cases. So here's my conclusion. Z equal to a negative 3.75 is sufficient evidence to reject our null and now conclude and I have to conclude the alternative, but I can even be a little bit more specific than just say it's not equal to. Notice our number 17.1 was on the left side. I can conclude that it's less than 18.6, and I need to put that in context. So I'm going to conclude the following. The average monthly investment in the bond market is less than 18.6. Conclude the average monthly investment in the bond market is less than 18.6 million. Notice 1, 2, 3, 4, and I'm basically making the rejection at all 4. Compare that now I'm going to do the p-value over here. Step number 1, just to save time, it's going to be exactly the same. Again, I want to emphasize on your test or on your assignment, if they tell you to do it both, you can't write the same, you got to write it out. Step number 2, I'm going to list the multiple alpha levels. I will not need these rejection regions, but I will need the size of the sample and the type of statistic, like I did over here, a Z statistic. Step number 3, I'm going to calculate it the same. If you don't mind, I'm going to skip the formula here and the substitution. I'm going to go right to the negative 3.75. The previous example, we listed our p-value as 2 times something. This time it's about 2. Last time I had to subtract some quantity, but because this one goes off the edge, basically I'm subtracting all of this, which is 0.5. I'm going to have an approximate 0 probability of getting this sample if the mean price is actually, our mean investment is 18.6. The likelihood of getting this kind of sample, I had a probability of just about 0. Because it's that low, it's lower than all of my alpha levels. Okay, my step 4 is I'm going to say P approximately equal to 0 is sufficient evidence, and I'm going to have the rest to be exactly the same as what I had over here. What was different? Here I had rejection regions. Here I had a p-value. Listen carefully once. Those are basically doing the same logic. They're basically making the same logic. This just uses the probability that it's that far to the edge. This one uses specific lines that they draw in the sand. But it's the same logic, just different ways of thinking about that. Now, one thing I would like you to show you once is this. What if this sample, that means up here, sample of 36, what if it had been 17.9 instead of 17.1? If it had been 17.9 instead of 17.1, then the z-score would have been a negative 1.75. My line in the sand would have been right here at a negative 175, and the p-value would have been 0.04. Rather than 0, it would have given me 0.04. Okay? Now, if my p-value had been 0.04, 04, what was it, 01? If it had been 0.0401, it would have been less than 10%, which means I could have had sufficient evidence at 10%. 0.04 is less than 0.05. I would have had sufficient evidence at 5% alpha. 0.04 would not have been less than 1%. We would like to have sufficient evidence to conclude a statement rather than continuing to have to assume. So I'm going to look for what is the strongest statement I can make here in these conditions. I'm going to say that again. What is the strongest statement? Well, my strongest statement is when I can reject at the lowest level possible. In this case, 0.05. So I would have said the following. Watch how this would have changed my conclusion. I would have said P equal to 0.0401 is sufficient evidence. Notice how I'm going to write this now. I'm going to put it in red. Sufficient evidence, here's the key, at alpha equal to 0.05. That phrase gives me my strongest statement. At alpha 0.05, 2, reject, null, blah, blah, blah. Same conclusion that I had over here. Now, that z-score would have been a negative 175 instead of this one. So if my z had been a negative 175, do you see that that would have been over the top, over the line for this one, because a negative 175 is less than that. It would have also been, in this case, I gotta get my bearings here straight. It would not have been less than those two. It would have been less than just one of them. So I would have had sufficient evidence to reject because I would have been over this one right here, a negative 1.75. And I would list that in that corresponding manner. Okay? Stop there. That's a little confusing, I know. I'll do more examples like that in the future. Most of the time, I will not give you on a test 3 levels. You might see it in your book, but it's a little bit more unusual. I think we're actually going to make this our last example here today. And I'll take the 4th example as a review, hopefully on our next lesson. All right? So read through this one once. It's again a 2-tailed test. And I'm looking to do both a critical value and a p-value test. Most of the time, they will just ask you to do one or the other. I am continually showing you both to help you get used to it. Notice we're considering whether it averages 50 minutes or not. Average of 50 minutes, let's like saying average is 50 minutes. That's screaming at me 2-tailed test. So step 1, the null and the alternative. The null is that it equals 50. The alternative is that it does not equal 50. Let's just put that one over here right away as well. The null, the mean equals 50. The alternative, the mean does not equal 50. Step number 2, I list my alpha levels. They said test the claim at a 1% significant level. That means your alpha is 1% or 0.01. We took a sample of 70, so my n is equal to 70 in both cases. Because that's more than 30, remember n greater than or equal to 30, because it's more than 30, I'm going to be using the z-stat. I know that seems like that's what we're always using, but we'll be using different ones in the future. We're starting these out by staying fairly consistent. Now, there's a little bit of a change. Critical value means I need my rejection regions. So I need my rejection regions. It's going to be z is less than some negative number, or z is greater than some positive number. That in red will not be over here. Let's find those lines in the sand once. Again, this drawing, this picture is not needed. It's just to help you understand what the test is actually showing. I'm testing against 50. I'm looking to see if it has enough evidence on the left or on the right. We got to consider that it could go both ways. My line in the sand is from 0.01. Because it can go either way, I got to split that 0.01 in half. So that's 0.005, 0.005, which gives me 495 in each side. This would be like a 99% confidence interval. That would be 2.575. Remember those numbers from memory? 2.575 negative on that side. So if I go less than that negative number, that's right here, less than a negative 2.575, or I go over the positive one, greater than 2.575. Those are my two rejection regions. If it falls over here, or if it falls over here, I've got enough evidence to say 50 must be wrong. I don't list that rejection region in the p-value. So step number 3, I find my z-score. My formula again, x bar minus mu divided by s over the square root of n. My sample mean, let's find out what it was. Took a sample of 70, found the average of those 70 is 47.2. So my x bar, 47.2, minus mu, which is always up in the null and alternative at 50. It's less than 50, so it's going to be looking over here someplace. The question is, does it go over this line? My standard deviation, 18.9, divided by the square root of my sample size, 70. Well, you got to calculate all that out. And again, that's going to be something they would expect that you can do. Let's talk about what that would be here once. Turns out to be a negative 1.24. Well, do you see that a negative 1.24 does not get into that rejection region? 1.24 is about over in here someplace. It's not so far away from 50 that we believe 50 is false. It's within reasonable variance because we recognize taking some sample, we're not going to hit 50 exact every time, but it should be reasonably close. And this 47.2 was reasonably close. Therefore, this number is not in that rejection region. What does that mean? It means z equal to a negative 1.24 is insufficient evidence to reject the null and thus we continue to assume now I want to put it in context. What am I assuming? That the average number of minutes for employees to get to work is 50. The average number of minutes for an employee, I'm out of space here, I apologize, I'll slide that out. For an employee to get to work is 50 minutes. Key phrases that I'll be looking for: insufficient evidence, and I continue to assume. That phrase must be in there because it's going to help you understand what these tests are about. Okay, now let's go back over to here and look at the p-value test. Okay, step number 3, I would find the exact same z in the same manner I'm just going to go with a negative 1.24 rather than writing out the formula. But now this part is different, that p-value. Remember that p-value is 2 times each tail. Well, how do I get the tail for 1.24? A picture of what's going on. I have a negative 1.24 z-score. My p-value would be this tail plus this tail. That's why we take 2 times each tail. So what is that tail? Well, I find 1.24 and find this probability from the chart. So if I do that, it would look like this off the chart. Z is 1.24. I get 39.25. That's the middle out. 39.25. 39.25. This tail then is 0.5 minus the 39.25. That's what's going to go in here. 0.5 minus 39.25. What does that p-value turn out to be? Turns out to be 0.215. Well, what does that mean in context? Recall again, we compare it to our alpha. If this is less than alpha, I have sufficient evidence to reject the null. If this p-value is greater than alpha, I have insufficient evidence. Just like this one had insufficient evidence, so will this one. So my step 4, p equal to 0.215, because it was not less than my alpha, it is insufficient evidence. Blah, 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 which of course you would write out, but it would be the exact same statement as what I did there. All right? Any question? Or I shouldn't say that. If you have questions, don't be afraid to email me. Don't be super concerned about the multiple levels of alpha. That'll show up more frequently in an assignment, but not on the test. I'm more concerned that you can do it with one specific alpha. You should have the same decision when you're done. No new assignment. When we come back, I'll be doing a lecture on both critical value and p-value tests, but they will be not two-tailed, but they will be single-tailed tests. I'll review one of the two-tails first and then go right into the two-tailed or the single-tailed test after that. So no new assignment on this particular video. See you next time.